Hello students, how are you? क्या चल रहा है? Welcome to my channel. Today I shall discuss one important topic in chemical kinetics known as temperature dependence of rate of reaction. This is also known as Arrhenius equation. Most of the chemical reactions gets accelerated by increase in temperature. For example, if we increase the temperature of reaction mixture of potassium permanganate and oxalic acid, then the potassium permanganate gets decolorized faster. It has been observed that by increase in temperature of the reaction mixture by 10 degrees centigrade, if we increase the temperature of reaction mixture by 10 degrees centigrade, then the rate constant becomes double. Rate constant becomes double. It means that the rate of reaction gets double by increasing the temperature 10 degree centigrade. The temperature dependence of rate of reaction was first studied by J.H. Van Top, and its physical interpretation was given by Arrhenius, known as Arrhenius Equation, which says K is equal to rate constant K is equal to A e की power minus EA upon RT. This is known as Arrhenius equation. Here K is rate constant, you know K is rate constant. A is known as pre-exponential factor. A is known as pre-exponential factor. A is activation energy. A is called activation energy. Here A is activation energy. T is absolute temperature of reaction mixture. Absolute temperature of reaction mixture. R is a constant. Its value is 8.314 joule per Kelvin per mole. This equation is known as Arrhenius equation. Now let us take one example of formation of product. When hydrogen molecules collide with iodine, the formation of hydrogen iodide takes place. When hydrogen molecules collide with iodine molecule, then the formation of hydrogen iodide takes place. This formation of product can be explained as in the reactant there is a bond between two hydrogen atoms, and in iodine there is also a bond between two iodine atoms. When they collide, the bond between two hydrogen atoms are being broken. Similarly, the bonds between two iodine atoms are being broken. And in the same step, the formation of bond between hydrogen and iodine atoms takes place. And finally, this is the intermediate step. And finally, the formation of product 2HI takes place. Two hydrogen iodide molecules are formed in the product. Now we can explain the formation of hydrogen iodide by graphical representation in the form of potential energy diagram. This is the potential energy diagram for the formation of hydrogen iodine molecule. X-axis contains the reaction coordinates. At x-axis we have reaction coordinates, and at y-axis we have potential energy. Potential energy. Here in this case the reactants are hydrogen and iodine molecules. This is the energy of reactants hydrogen and iodine, and the formation of product HI takes place according to this graph. This is the energy of activated complex. This is the energy of activated complex. The difference in energy between the reactants and activated complex is known as activation energy. The energy of activated complex and the energy of reactants, this is the difference between them. This is known as activation energy. This energy must be supplied to reactant molecules in order to get converted into the products. HI is product. Here they are reactants, and these are products, and this is activated complex. And the difference between the energy of reactant and product, this difference is known as delta H, enthalpy of reaction. This difference between the energy of reactant and product is known as enthalpy of reaction. This is known as enthalpy of reaction. The amount of delta H depends upon the nature of reactant and product. If we take different reactants, then the delta H will be different. The energy may be released during the formation of product, or energy may be absorbed during the formation of product. It depends upon nature of reactant and product. Next, we shall discuss about most probable kinetic energy. What is most probable kinetic energy? In a reaction mixture, there are large number of molecules. So we cannot specify the kinetic energy of a single molecule. For this purpose, Maxwell and Boltzmann use statistics to define the most probable kinetic energy. If we plot kinetic energy Ke of molecules against fraction of molecules, then we obtain a graph like this. The kinetic energy possessed by maximum fraction of molecules, is known as most probable kinetic energy. This is the kinetic energy possessed by maximum fraction of molecules. Okay. Below this, the number of molecules decreases. The number of molecules having energy are less than this, most probable kinetic energy. Now, we study the effect of temperature on most probable kinetic energy. What happens when we increase the temperature of reaction mixture? Let us consider. This is the most probable kinetic energy graph. This is the most probable kinetic energy graph at temperature T. This is the most probable kinetic energy. This is fraction of molecules. One on y-axis, and x-axis contains kinetic energy. This is the most probable kinetic energy at temperature T. Now, if we increase the temperature by 10 degrees centigrade, the curve broadens out and the most probable kinetic energy goes forward. This is the curve. This is the most probable kinetic energy at T plus 10. If we increase the temperature by 10 degrees centigrade. If This is the activation energy. The molecules having energy more than EA are able to form the products. This is the activation energy. If a molecule have energy equal to or more than activation energy, then the formation of product takes place. And let us see what happens when we increase the temperature. We can see that by increasing the temperature 10 degrees centigrade, the number of molecules having kinetic energy greater than activation energy increases. At lower temperature, this is the graph, area of the graph. There are lesser number of molecules having energy more than kinetic energy, but at temperature T plus 10, the number of molecules having energy more than activation energy increases. Therefore, the formation of products takes place faster. More product formation takes place. Let us consider H2 plus I2 2HI. If we increase the temperature by 10 degrees centigrade, then the number of reactant molecules, hydrogen iodine, having energy greater than activation energy increases. Therefore, the number of product molecules HI also increases. Since the number of molecules having energy greater than activation energy increases, so the formation of products takes place in large amount. This is the representation of most probable kinetic energy with temperature. We can also see that the graph broadens on increasing the temperature, but the area under the graph remains constant. The area under the graph remains constant. Thank you for watching my channel. Please like, subscribe and comment. Your comments are welcome. Your feedback is required for this channel. You can suggest me any other topic in the next lecture. Thank you.